Okay, so with that, I would like to introduce our first speaker, and this is going to be a recorded presentation, but the speaker is here live to answer your questions at the end of all our presentations. So our first speaker is Julie Elliott. Julie is an NRCS liaison to the Northern Plains Climate Hub for 2021. Julie is passionate about conserving natural resources through sustainable agricultural practices and delivering educational opportunities. She's particularly interested in helping landowners develop the knowledge, skills, tools, and confidence to strengthen their range management strategies before, during, and after drought. Over her 30-year career, she has organized 84 workshops that have reached 4,757 people. Raised on a small ranch in eastern Colorado, Julie is a first-generation college graduate, and Julie and her husband, Tom, have one grown daughter who lives in Kentucky and works as an airplane mechanic for a charter business jet company. So welcome, Julie, and I'm going to share my screen and share that recording now.
Hi, I'm Julie Elliott. I'm Rangeland Management Specialist with the Natural Resources Conservation Service and a liaison with the Northern Plains Climate Hub. Before I get started, I just want to note that Grasscast is made possible by a collaboration between the U.S. Department of Agriculture, several universities, and the National Drought Mitigation Center. Grass growth is a complex process hinged on the right amount of moisture at the right time. As weather forecasting is unreliable at best, no one knows for sure how much moisture we're going to get until the growing season's over. But cattle markets fall, hay markets rise, and the range is damaged in a way that may last for years or even decades if we're waiting too long to reduce forage demand in the hopes that the grass will end up growing. This has negative effects on the rangeland as well as the culture and the livelihoods of the people. Therefore, Grasscast was created to see what grass production might be lying ahead in the coming growing season. Grasscast takes soils information, plant communities, past weather information, puts it all together to create a current soil water profile. It adds future possible temperature and precipitation scenarios to create a total production prediction. It uses 3 precipitation scenarios. One for above normal, one for near normal, and one for if the spigot shuts off and we end up with below normal precipitation totals. And presto, we have Grasscast maps. Now, there's a lot of colors and it can seem pretty overwhelming, so don't panic or shut down. I'll walk you through taking these maps apart so that they are meaningful. But first, I want to make sure we understand. Grasscast maps are based on observed weather to date, plus future weather scenarios. We're saying we expect grassland productivity in your area to be some % higher or lower than the area's 36-year average. Arizona and New Mexico have 2 green up events. You have a spring growing season and a summer growing season. So we have 2 maps, one that'll close out in May for the spring and one that'll close out the end of August for your summer growing season. So let's look at the Grasscast maps. There's a color code. The blues mean above average, the green is near average production, and the yellow to red hues are below average production. So we're going to use Chavez County, New Mexico, outlined in black. For above average precipitation, our production prediction is around normal, 5% below to 5% above the long-term average. If we go to near normal precipitation, however, our county turns orange. And the key tells us orange means 15% to 30% less pounds per acre than the normal production. And if we go below average precipitation, if the spigot shuts off, we end up with red in our county. And red tells us there'll be 30% pounds per acre or less. But where do we lay in that county? And how does this production prediction relate to us? We can go to the zoomable maps on Grasscast. Grasscast is built on 6-mile by 6-mile grids, so you can get in pretty close to wherever your interest area is. Make sure you remember to click the Southwest radio button so you get the Southwest maps to come up. Use the magnifying glass to type in a town near you or type in the county. Just be aware that if you type in the county, you're going to get the geographical center of the county. You can use the plus and minus buttons to zoom in and out, and then use your mouse to click on the grid cell that you're interested in. Again, the maps come up in the same order, so the left-hand side is above normal precipitation, and our production prediction for the grid cell I picked is 3% less than the area's 36-year average. In the middle is near normal. For this grid cell, the more precise prediction is 21% less pounds per acre than the long-term average. And below normal precipitation on the right-hand side, 32% less pounds per acre than the area's 36-year average. Wow. Well, which one of these maps is more likely to occur? For that answer, we go to the NOAA Climate Prediction Center. They have both 30-day and 90-day precipitation outlooks. If you want to use the interactive display, because we're looking for the May or the spring growth, we're going to use the 30-day precipitation outlook. You can use your mouse to click on the location on the map, and it puts a pin there, and then it pops up with this pie chart giving their confidence of the different precipitation scenarios: above normal, below normal, or near normal precipitation. In this case, we can see there's a 46% confidence that, or 46% chance that there's going to be below normal precipitation for this area. But that still leaves some chance for near and some chance for above precipitation. So let's go back to our GrassCast maps and see what we can make of all this. GrassCast maps are made by taking the last 36 years of precipitation and stacking it up. The driest years make the bottom maps. The driest 12 years make the maps for the below normal precipitation. The wettest 12 years make the maps for the above normal precipitation, and the years remaining in the middle make the near normal precipitation prediction. So think of it this way: what's the likelihood, based on everything that's happened in 2020 and so far in 2021, what's the likelihood that the end of May will end up being some of the wettest of the last 36 years? On the other hand, what's the likelihood that the end of May will end up being near normal or even below normal? When we think of it this way, it's much easier to see that our odds are much heavier stacked towards the below normal or the near normal precipitation prediction than the above normal. In fact, there's 79% chance that we're going to be in either the near normal or below normal precipitation prediction. And both of those are drastic reductions in overall production. There's lots of tools out there. GrassCast is one of them. So let's not put all our eggs in the GrassCast bucket. You should be checking the Drought Monitor, which I'm sure most of you are familiar with this. It reflects current climate conditions, precipitation, temperature, evaporation, and other climatic factors. The colors represent the intensity of the dryness. And then they have long-term and short-term drought effects on the big map when you pull it up. A tool you may not be familiar with is VegDry. VegDry takes the climatic data and translates it into vegetation health, or greenness versus dryness, the quality of the vegetation. This is a current picture. It's a real-time picture, not a forecast and not a hindsight picture, as of the day that the maps are made anyway. But all these tools do not replace your monitoring and your observation. What's happened so far in the last year, in the last month, in the last week? Where are you today compared to where you would expect to be at the end of April? How's your rotation working out? Are you having to move sooner than you had planned to leave the amount of vegetation behind that you need to maintain your range health? How are you working compared to trigger dates and conditions that you've identified indicating that you need to make a change? Rangeland management is both science and art. These tools and other tools that are out there, they're the science part. But the interpretation and decision making, that's the art part. And they're both equally important. GrassCast is an end of the season forecast. It is not what's going to happen in the next couple weeks. It is not a substitute for going to your pastures. It is not an excuse to do windshield monitoring, driving by 55 miles an hour, seeing how your rangeland looks. This is how it might look when you're out looking for your calves or checking salt and mineral. When you look across, you see these beautiful green grass. Green is a dangerous color. It has an intoxicating effect on us in rangeland. But when we get out of the pickup, get off of the four-wheeler, put our boots and our eyes on the ground, we see a whole different picture, don't we? You can see my keys just to the left of the center of this picture. This picture was taken looking down in the center of the focus of the picture above. GrassCast cannot tell you what's desirable or undesirable. GrassCast does not know if you have annuals or perennials out there. GrassCast does not know if you have weeds. GrassCast is built on 6 mile by 6 mile grids, which may be really good for you, or it may not. Those grids may not represent your range. They may represent more or less moisture. It does not GrassCast does not know the state of your vegetative cover. It doesn't know how tall the grass is. It doesn't know how healthy it is. It does not know how much root system you have underneath your plants. GrassCast does not know how much litter is on the ground, and it does not know if the precipitation ran off, if it soaked in, or if it evaporated. Therefore, GrassCast should not be used by federal land managers or absentee landowners for setting how many number of head can go out on a range. It should not be used to determine what day they can go on or what day they have to come off. It definitely should not be used as a range monitoring technique. GrassCast should also not be used for documenting grazing losses. GrassCast is a total production loss or total production exceedance prediction. Total production is divided into 3 buckets. The first bucket is what's left behind for the health of the plant, usually about 50%. The next bucket is what's left aside for wildlife, grasshoppers, and losses due to trampling, urination, or defecation being laid on. The last bucket is what's actually allocated to the animal, what goes into their gut. Total production loss does not represent grazing loss. When you have total production loss, that first place that loss comes out of is the grazing bucket. Grazing loss is higher than total production loss. To learn more about GrassCast, go to grasscast.unl.edu or type GrassCast into your favorite web browser. Be sure you remember to click on the Southwest Radio button. There's a frequently asked questions box, there's introductory video, there's a great how to read the maps tutorial, and there's historical productivity if you'd like to know more about how GrassCast is making its map. If you have any questions, please contact us. GrassCast is new to the Southwest. This is just the second year, so we're still learning along with you. So please tell us if the final maps, particularly end of May or the end of August, do not represent what you see on the ground. But if you have any questions or would like us to visit with you more, please don't hesitate to contact us. And I thank you for your time.
All right, thank you, Julie. And as I said, if you have any questions for Julie, just go ahead and enter them into the chat box and we'll get to them at the end. We also have Lauren Kramer on, who is with the USDA Southwest Climate Hub, and she also works with GrassCast. And so she can also attend to your questions at the end.